All right, on to the next session. Now we're going to be talking about messenger priorities for the client with How Mai. How Mai, you want to give us an overview of the blueprint?
Yeah. Uh, would you see the slide?
They look good.
Okay. Okay. Uh, my topic is give a simple model about priority, the client, and connection. So it is a little like the yesterday's topic of Josh, and this topic mainly addressed this problem. For example, different workload. I mean that if we share the recipe way with RBD for the same cluster, and we need to get the different QoS. For example, RBD need more LPS and less bandwidth, and RGW need less LPS and can bear for high latency. The second is unbalanced benchmark result. For example, if we have one cluster and the right IOPS is 100,000, and if each client could eat most of IOPS, and the later client will get little, and we can see some case and in some clusters. For example, if we have 4 clients and the first client we started early and it will consume 90,000 LPS, and the later 3 clients only will eat 3,000 LPS. Okay. And and we want to implement a simple priority model to address this problems. At first, we needed to add a priority to connection handshake session. So each client will have a priority, and it will send and OSD will receive these messages and queue the message to the specific priority queue. For example, we will have messages received priority queue and OSD-OP priority queue and Federal queue. These three both used for priority first. And I think this model is simple, but may work as we expected. So at least it can address some problems for unbalanced client workload, unbalanced client benchmark result, but it can't provide with good QoS control. For example, we can't give a detailed IOPS or latency to the client, and it can get the right IOPS. And this is existing priority queue, and but we actually don't make it work very good because we disable the token-based priority queue function. For example, if priority larger than 63, we only use priority subqueue, and it will much like FIFO. And if priority less than 63, and actually we use token based and token based message distribution. So I think if we want to make a priority queue work better, then now we need to enable the later method and we need to avoid the performance problem. I think I'm not sure why we disable this, but I think it is a performance problem. Is it right? Yeah, some.
You there?
Oh, are you asking if I'm here?
Yeah. He was.
Yeah,
he had a
so
question for you.
hang on.
So
Sorry,
do you have
speakers.
do you give some background about Parity Queen? Why we disable token-based method?
Okay, so the purpose of the tokens is actually to prioritize client I/O as a whole against non-client I/O. It actually isn't intended to prioritize clients against each other because at the moment all clients are priority 63.
Yeah.
You're correct. This is a big fat opportunity for improvement. Oh yes.
Yeah. Okay. I think.
So
So
all I did was make it so that there would be some vague sense of fairness between clients, but that's it.
yeah.
Cool.
So I think maybe we need to implement or improve this Parity Queen to avoid the bottleneck for performance. For example, we need to refer to Linux TC algorithms. For example, SFK, which is a simple parity algorithm. And second, maybe we need to do some control for parity with performance relationship. For example, if one client can get the forecast performance capacity and the cluster total LPS is 30,000 LPS, and if one client is 100 priority and another is 50, we want to the formal client can get 20,000 LPS, and the later one can get 10,000 LPS. This is we want to get. So if we want to get the parity among the OID code, we need to make 3 parts codes work. The first is a message parity. I only give the example of async message parity because I think the simple message is a little difficult to implement this. At first, we will have dedicated thread for each priority queen, and different and each thread will process the high priority connection at first. For example, if we have many connections connected to the OSD, and each connection will have different priority, and the thread will only process the high priority connection, and the threads will share the priority state for load bands. For example, the high priority maybe should be distributed well among these threads. And how we implement the priority works. Yeah.
Did you mean the high priority connection should be shared among the threads?
Yeah. Except the high priority and the middle priority or low priority should be distributed well. Yes.
Do you mean the set of high priority? This is important. The set of high priority connections should be distributed among the threads, or a particular high priority connection should be distributed? Okay, because you get ordering problems if you take a single connection and let multiple threads at the.
Yeah.
Okay.
Yeah.
Cool. Yep, that makes sense.
Okay. And the second, we will improve the existing PG queen, and I think the biggest problem is performance. I think we need to do some, but I don't have too detailed idea for this. But I think we need to address the performance problem. So based on the existing priority model, we need to do some changes. For example, now we have a messaging priority from 0 to 255, and we may use the middle range for the client connection priority range. Sorry, this is wrong. And the connection priority will be assigned to OST OP messaging priority to match the current implementation. And for example, recover OP and scribe OP is lower than 53, and we need to make this priority work as before. And the third is the file journal queue, and we want to make it is a queue like a priority queue. And for example, we need to do some heuristic algorithm to construct AIO by priority. Maybe we need to spell IOs by priority. For example, high priority will be constructor and be a single AIO1, and the low priority maybe be another AIO1. So it is maybe should be more smart based on heuristic algorithm.
I thought about this a little bit. One of the observations is that once you have done the work to improve the queues further up, by the time we get to the file journal queue, we've already decided to perform this I/O. So it's holding resources like memory, and it's holding locks. It's unlikely that we want to perform fair queuing in the file journal because we'll already have done the queuing one layer up, and presumably we'd have throttled in such a way that the file journal and the file store have exactly enough I/O to work with to fully saturate their queue, but not so much that they have extra queuing to work with, if that makes sense. Another challenge is that the best you could possibly do at the file store level is prioritize between what are they called? Op sequencers, because you can't do out of order writes on a particular op sequencer because then that would be an op unsequencer. In particular, if a PG processes two ops at different priorities, it doesn't matter. They went into the file or they went into the PG log in that order, and they must be completed in that order. So you have limited reordering opportunities in the file journal anyway.
Yeah.
But you might be able to do something like prioritize one pool over another, which might be valuable.
Yeah. So maybe there is only a simple algorithm. For example, it will only according the IO size or the transaction size or the priority, and get the original implementation to work. For example, if we meet a very large IO size transactions, and this is a low priority, and the next is a high priority, we may need to filter two transactions into two AIO structure, and maybe something like this. Some simple heuristic algorithm.
That's the problem. If the file journal queue has a high priority item followed by a low priority item, or a low priority, if it has a low priority item followed by a high priority item, you still must complete the low priority item first, unless we attach some metadata that says that they're in different pools.
Oh, okay. I know.
If they're within the same op sequencer, you can't change the ordering, so scheduling isn't going to help you.
Yeah. Maybe
I might be misunderstanding though.
Yeah. Okay. The result we expect at least we can make high priority client have better performance than low priority client. Maybe we don't have the detailed performance control, but we want to at least get the better performance. Maybe this is not very good enough. And the same priority client could get the balanced performance. And the third, maybe we can get a performance relationship between the two different priority clients, like I said on these questions. So this is all I talked about priority queue for the OSD side. Yeah.
So you may be interested in, there's some other work being done by Sayed on RBD, on creating some architectural changes that would allow RBD to get essentially scheduled I/O for losing the word QoS.
No. I think this model is very simple, and we not only need to make each client change the add the priority configure view, and this is enough, I think, for client side.
It's enough. Well,
yeah.
So in a particular OSD, that's kind of true. The problem is that you don't know whether the client has done a bunch of I/O elsewhere.
Yes.
Don't get me wrong, this is all very good. I'm saying that the other work is also in the priority queue area, and you guys might benefit from communicating. That's just now starting though, so you might catch him on Ceph Devel. I'll see if I can introduce you next time I see you both on IRC.
So, sorry, I have some question here. The first question is that since currently all the clients share the same priority, but we still didn't get the fair or same performance among all the clients. So I'm not seeing any change in this blueprint can address this problem. Is that true?
Yeah. I think my topic is mainly just this problem, and we can get this result. I hope. Yeah.
And another question is that I remember some years before, we reduced file store journal queue length or file store queue length to something smaller. The main idea is that we want to keep the any queue below the priority queue to be relatively shorter, so that we could benefit from the OSD priority queue. So I'm not seeing why we need to implement priority queue in files journal queue, because that we can make the queue a little bit shorter, say 50 ops or something like that. So the throttle will help you to do the balance.
Yeah, maybe. Yeah, maybe it is useless. Maybe, yeah. I'm not sure. I think this topic just like maybe is a problem thrower and not a future. Yeah, I think it is, and I think this is maybe is a problem. For example, we can't get the balanced performance among the clients, and we need to make it work and better. So maybe it's just throw some problem, not get some new features done. Yeah.
Yeah, and the last question is that we disable the token-based priority queue for client ops. Is that a performance consideration? And since the code is already there, so that means that if we enable the token-based priority queue, is that address the problem?
I think before enable this priority queue based token, we need to address the performance problem. Until we throw the performance problem, we want.
So the first question is that a performance issue to make us disable the token-based priority queue?
Yeah. So at first we need to throw the performance problem.
Hang on, I did have another question. So are you saying you measured a thing where the priority queue itself is costing a lot of CPU time?
Yeah.
Okay. Do you have those benchmarks? or not the benchmark rather, but the
yeah, I found it nearly consume nearly 10 US each for each IO and computer the token. If the current is full or much more, the compute time is much more. Yeah, it is based on the current depth of the priority current. If the
actually it's the number of priority levels, but
yes, exactly.
But usually there are only two. That's one of the reasons the current implementation isn't too bad.
Yeah.
Usually it's just the 63 queue and the 10 queue.
Okay.
I agree though. It's a big waste of CPU. We can do better. My only concern is that SFQ doesn't actually, stochastic for queuing, I don't think gives you a way to do priority. Does it?
Yeah. I just rethink to make it. I want to get some ideas from Linux PC kernel module, and I want maybe we can do some works based on existing Linux kernel implementation such as SFQ. But I think SFQ is not good enough for our this module. Yeah, we need to do some changes, but we want to get some ideas from them.
Yeah, the only ones I was able to find were token based. Because the real purpose of that queue isn't fairness among clients. I mean, that's important, but at the moment, all clients are sent with the same priority, and we don't have any kind of global information anyway, so it seemed futile. What I really care about, the problem that queue is currently solving is scheduling recovery, snap trimming, and scrub work against client work. So yeah, whatever we replace it with, we'll need to be able to do that as well.
Yeah.
Hey, Haomai, so a couple of observations actually in the same point. So we also observed that, okay, two clients were not getting the similar priority. So we did some debugging here. So what we saw is that these shards actually are not equally distributed. That one of the reason means all the IOs on the different shards are actually, some of the shards are heavily loaded, some of the shards are not properly loaded. So you may want to look at that sharding scheme, which is very naive right now. It's just PG based, PG hash based. So that one of the things we observed. And the second thing actually we saw that largely because of this tcmalloc stuff, replacing that with jemalloc, we are not getting that imbalanced distribution between the clients. So, yep.
I'm sorry. So when you used tcmalloc, you saw a highly imbalanced performance between, I'm going to assume, librd clients doing random reads, and with jemalloc it went away.
Yeah, so that largely because of this. That's largely because of this tcmalloc bug that we reported, right? So that thread cache, each of the threads, they are actually putting the cache, and whatever the shards actually using, it's a heavily loaded using that part of the threads, right? So those are actually heavily consumed. So that actually becoming some imbalanced distribution.
By the way, if you're finding that the threads are imbalanced, there are only two ways that can happen. One is that you don't have enough placement groups on the PG or on the OSD, and the other is that the placement group seeds that are assigned to the OSD are in fact not uniform over the however many bits we're using to do the mod for the thread. So you might consider hashing them again. If you simply hash the PGT seed and then take that mod the number of threads, that should make it go away. If it's the second one, but if it's the first one, you simply don't have enough placement groups, then just increase the number of placement groups.
No, actually we have enough placement groups, so
okay, so it must be the second one. The distribution must be bad. I'm not sure how that could happen, although I guess there's nothing in Crush that makes me really confident that it would preserve a good distribution. I just kind of assumed it would. Okay, so yeah, that should go away if you use a good hash function on the input PG seeds.
Yeah. So yeah, we didn't dig down on that. So we found these things. So we saw that jemalloc is solving, and tcmalloc bigger thread cache value is also solving that issue. So we kind of move away from that. So, but I think that probably kind of one of the root cause of the imbalanced performance between the clients.
Yeah, maybe it's a good point, and but I'm not sure the detail of this malloc why it plays very bad for this.
Well, different threads, keep in mind, are pulling with at least with the standard messenger, are pulling information off of the connections. So it's not super surprising that there could be a bug in TC-malloc where memory allocated in one thread turned out to be much less effectively utilized in a different thread if it was failing to pull from the thread local cache or something like that. I could believe that.
Okay.
Surprising, but somewhat believable.
So it seems
we're using TC-malloc in the first place because the standard libc-malloc is like much worse, dramatically worse. It's surprising. Anyway.
Yeah.
So another aspect of this that we didn't really talk too much about in either the QoS session or this session yet is kind of the emission control portion, where you might want to, if you're trying to guarantee that clients receive fair shares, you might want to perhaps measure the apps that your OSDs can do and prevent you from oversubscribing by having too many clients connected, or more than your cluster could handle. Do you think that kind of thing would be useful, Hamai, in your use cases?
Oh, connected or too many messages in memory?
Well, it could be either way.
Yeah, I hadn't thought about the connected one, but that's a good point.
Yeah, I think this is a good point, and we need to cooperate.
In principle, it's not too hard, right? The OSD is basically free to boot any client connection it wants to. So we could do a when we get into that case, we could do something like every time you commit three operations, we kill your connection and you get in line again.
I wasn't even thinking about at the OSD connection level, but more like the connecting to the cluster level.
Oh.
So like with the PG stats or with other statistics, the OSDs could be reporting their IOPS capacity to the monitors, and the monitors can keep track of how many clients are connected potentially, and then deny new clients if there are already as many as the cluster can handle with given reservations. It's not the friendliest approach in terms of denying connections to the cluster at all.
Well, it's also weird because if you're even remotely conservative about it, you'll reserve to way below the cluster's actual throughput because flash mobs are going to happen. So if you want to have a high probability of an OSD not being overloaded, which is what you're really trying to avoid, you'd have to way undersubscribe.
That's true. Yeah. Perhaps it might be more useful just as I'm kind of measurement for administrators to see like what the cluster is actually doing and what different clients are actually doing, how overloaded the individual OSDs are compared to their capacity. Which is the portion where OSDs are just reporting their IOPS capacity and what their current load is, without actually doing any kind of enforcement, would be more useful.
Yes. Yeah.
But yeah, that is an orthogonal piece, though. It's kind of something totally separate from the queuing mechanism. So I'm a little skeptical about the stochastic fair queuing algorithm providing like fairness in general. Like it's optimizing for fairness across different clients, but not actually trying to guarantee them any kind of IOPS reservation.
No, it's fairness in the simplest sense. I mean, it's valuable. It's just it also doesn't guarantee. Wait, no, it does. Right. Okay. So just for the record, if you were looking for someone to fit that into the prioritized queue, it would fit in under the token bucket, but above where I do a round robin thing on the clients. You'd replace the per entity inst queues with a SFQ scheduler that hashes the entity inst into one of the buckets and then does round robin on that. But it wouldn't replace the token bucket part.
Yeah. Maybe this is a way to do. Yeah.
The thing is, I don't think that's the expensive part. All it's well, I guess it might be. If you have enough clients, maybe it's wasting a lot of memory. It's hard to say.
Yeah.
But that the DQ part still isn't linear in the number of entities. It's linear in the number of priorities.
Mm.
Yeah, a lot of the QoS type algorithms end up treating things in the end as an earliest deadline for a scheduler and dealing with things in terms of deadlines instead of priorities directly, which should be much simpler in the DQ path.
That's true, but you still need a way to translate the IOP scheduling into deadlines.
Into the deadlines, yeah. Right, which is basically the topic of all the recent literature.
And actually, the thing with the recovery stuff is that it doesn't matter when it happens, only that for every n pieces of work you do on behalf of the client, you accomplish k pieces of work for background. That's the intention of the current scheduler.
And that kind of thing can be easily encoded as a proportional weight for recovery versus client IO.
Right. I mean, that's how the priorities are currently interpreted in the token bucket scheme. It's a priority. Mm-hmm. It's a proportional weight.
I think that's all the comments I had. Anybody else?
All right. Sounds good.